Hi, everyone, and welcome to another Be My webinar. We'll be starting very shortly. Once again, we'll be starting shortly, folks. Hi, ladies and gentlemen, and welcome to another Be My webinar. I'm Fernando, and once again, it is a pleasure having all of you here. In this session, we have Jack Franklin, who will be going over testing React applications. Jack is actually a JavaScript professional. He's been working in jQuery and React for the longest. And without further ado, I'll give it to the man of the hour, developer, evangelist, and pusher, Jack Franklin. It's all yours.
Cool, thank you. Hey everybody, thank you Fernando for inviting me on. It's really good to be here. As you said, my name is Jack. I'm Jack_Franklin on Twitter. Today I'm going to be talking for about half an hour or so on testing React applications and my experience of doing so. I'm going to show quite a lot of code and things throughout the presentation. At the end, I've got a few links to like GitHub and the slides and all the rest of it. So please don't worry about all the code I'm showing you. I will send you links so you can go and get it and run it on your own laptops as well. And I can put the links into the group chat on the Google Hangout too. I believe there are questions at the end as well. So put your questions in and then we'll answer some of those later on. Yeah, but without any further ado, really, I just want to get started. So I work for a company called Pusher, first of all. Pusher is a hosted real-time API platform. We make it really easy to build real-time features into your web apps or mobile apps. That's of interest. We're at pusher.com, or you can follow @Pusher on Twitter. Feel free to ping me if you've got any Pusher-specific questions as well, and I'm more than happy to talk about that. And I'm Jack Franklin. You can find me on javascriptplayground.com and on GitHub as Jack Franklin as well, and on Twitter with the underscore between my two names. So today I want to talk about testing React applications, my experience of doing so, and just show you a few of the kind of tools I use every day when testing my React apps. We test because it gives us confidence in our applications that work, especially if you've got a big team on a large application across more than 1 or 2 developers. It's very easy for a team on working on feature A to break a bit of the another feature that already exists. By having tests around those features, we can be confident that the functionality of the application is working as we add more developers and more code to the code base. It's also really nice for fixing bugs because you can replicate a bug in a test and fix that test. And then not only have you fixed that bug, but you've also ensured that bug can never happen again because you've got a test now covering that. And I've found in my experience, testing enables teams to move quicker, easier to refactor because you've got those tests there to back you up. And generally, they're just a great thing to have. This is a very dreadful Shakespeare pun about TDD or not TDD, but the point here is something that I've noticed is in React applications, I tend to write my components first and then write the tests. This is kind of contradictory to my experience in, say, Ruby or regular JavaScript, if you like, where I'll often write the test first. There's no hard and fast rule here. It's really whatever suits you, but I find personally with React, I like to write my components, get an idea of how they're going to work, the functionality that's inside them, and then write the tests afterwards. But you could definitely write React tests first like you would with any other language or framework. Before I go into the React specifics as well, there are a lot of JavaScript testing frameworks available. The one I use is called Tape. It's pretty minimal and gives you kind of the bare bones, which is the reason I like it. However, I've also used Mocha, which is very nice. There's Jasmine. There's Jest, which is by Facebook. There's a whole load of them. I'm sure there are 20 more I could mention here. All my code examples are going to be using Tape, primarily because that's my framework of choice. However, the actual core of this talk about testing React is framework agnostic. So if you hate Tape and you use Mocha, it's absolutely fine. The actual tests themselves don't depend on a particular framework. So even if you hate Tape, you know, there should still be a lot of good stuff in here for you. Finally, as well, I'm going to be using some of the latest ES 2015 features. I'm running it all through Babel to get it working. The main thing I'm using is arrow functions, which are just a nicer way of writing regular functions. They're a bit more slimline. They behave slightly differently in a couple of situations, but we won't need to go into those today. I'm also using the ES6 or ES 2015 module system. So rather than using the CommonJS requires, I'm using the import statements. But again, that's really all I'm touching upon. You don't need a good knowledge of ES 2015 to take anything from the talk. So if we first start with just a basic test in Tape, just to give you an idea of how these tests might look. Hopefully you can see my mouse there if it's moving. The first thing we call this test function. We give it a string, which is the description of the test, and then a function that takes in an argument, which is the thing we then call tests on. So see here, this adding numbers test. I have a function that takes one argument t. I can then nest my tests by just calling test again. And then down here, I have the actual assertions. Tape requires you to tell it how many assertions you're going to make. So in this case, I say t.plan1. And that means, hey, Tape, I'm going to run one test in a minute, or one assertion. The reason this is useful is because if you have asynchronous tests, you don't have to kind of hook them up to Tape. Tape just knows that you're expecting a certain number of assertions, and therefore it will wait a certain amount of time for your test to complete. And here in this test, I use t.equal to assert that 2 plus 2 is equal to 4. Down here, I use deep-equal, which compares objects to assert that this object matches this object here. That's really all Tape gives us, which is one of the reasons I like it. And also one of the reasons I like using it for talks is because I think it's fairly minimal and there's not too much to explain. So just a quick recap, we use t.plan to tell Tape how many tests you're expecting. This means Tape handles asynchronous tests really well. We use things like t.equal to check two things are equal, t.ok to check a thing is truthy, deep-equal to compare object, and there's a few others as well. It's got good support for running through Babel for converting ES 2015 specs, and the repo I'll link you to at the end has all this configured for you, and it's pretty minimal. There's not too much of a surface area to it. So to run the tests, I'll use a thing called Babel register, and this is something that will hook into any import or require statement and run everything through Babel. So it's a nice way to run your test without having to first do a big transpilation step. So in a typical project, I'd create a test script in my package.json. I'd run Tape, and you see here, this -r Babel register will load in Babel, so it will start converting all my files for me. I then just give it a path of files to watch. So in this case, this will run any test file that's in a directory called test and is named something-test.js. As I said, all of this is in a repository I'll give you access to at the end. So if I run that and I run my test that I showed you earlier, we'll get an output that looks somewhat like this. So adding numbers, 2 plus 2 equals 4. You'll see this OK1, which means that test passed. And you'll see this OK2, which means the second test passed as well. This is the output that Tape will give you by default. It's called the TAP output, which is the test anything protocol. The idea is that it's a standard way of outputting test results that's easy for computers to read. It's not that good for humans to read, however, but the reason it's good for computers to read means that people can write formatters around it. So if you don't like how this output looks, you can write your own formatter around it. Thankfully, there are lots of them out there. It's not designed for human eyes. I use one called Faucet. So we pipe our Tape output through Faucet. And if we run this, you can see it looks a bit tidier. So we've got some kind of green ticks there, and it's just tidied up a bit. There are loads and loads and loads of reporters available. One of my favorites is the 9cat version, which you can see there. There are loads of these. I'm sure you can find one that suits what you and your team want to have outputted. If not, it's pretty straightforward to write your own as well. So I'm not going to go too much into that other than just to let you know that these are available. You probably wouldn't use the cat in a real situation, but it's quite entertaining. So moving on to starting to look a bit more at React. React is actually really, really testable. I think people have a bit of a bad notion of what it's like to test frameworks because in the past, it has been very tricky to test something like Angular or Ember or these much larger frameworks. I should say, in the interest of fairness, that the testing experience for Angular and Ember is also pretty good these days. In fact, testing generally on the client side has come forward a long way, but I still personally find React the nicest to test. So to give us an app that we'll work on through the duration of this presentation, I built a little to-do app a long time ago when I wrote a blog post around Christmas time. So this is our to-do app. It's a quick video. I can click on a to-do to toggle it. I can hit delete to delete them, and I can fill in the box and hit a button to add a new one. As I said, I wrote this around Christmas time, so you'll have to forgive the Santa references that are now incredibly outdated. So that's it. There's not too much going on here. It's a pretty straightforward app. It's not using anything like Redux or anything big. We're kind of keeping it quite straightforward. This just to give you an idea of how this app is laid out. So we have this app component, which is the top level component. I've got a to-dos component, and this renders a list of to-dos where each list item contains a to-do component. It's given the object that represents a to-do. So each to-do has an ID, a name, and a Boolean done field. Then it gets a couple of callbacks, done change and delete to-do. These are called when someone hits the delete button or when they click to toggle a to-do. And then finally, we have a add to-do component, which renders the add to-do form and has a callback called on new to-do, which it should call when the user has filled out the form and hit submit. So all the state is held in the to-dos component, and other components notify that component when data has changed. So before we dive headfirst into React testing, I want to talk a bit about just testing generally as well. And in React applications, what I found the best pattern to help me test is actually to embrace plain old JavaScript objects. Most of your complex business logic should actually exist, in my opinion, outside of your React components. Plain old JavaScript functions are incredibly easy to test. If you've got functions that take in some data and give you back either true or false or some new data or something, they're really easy to test. You don't have to set up React. You don't have to do any boilerplate to test them. They're just plain old functions. So one of the nicest patterns I've found is actually pull any complicated logic out of your components and into standalone functions. Your components can call out to those functions, but you can test those functions in isolation without having to boot up the React application. This is the biggest thing you can do, in my opinion, to make it much easier to test your React apps and even your Ember, Angular, whatever apps, writing plain old JavaScript as much as you can. So for example, in this application, the to-dos one, I've got a file called statefunctions.js. And this exports three functions, one toggle done, one called add to do, and one called delete to do. Each of them take the state of your application, so a big list of all the to-dos, and some extra information they need, and they return the new state, which has had some transformation applied to it. So toggle done, for example, takes in the state, and it takes the ID of the to-do, and it returns a new state where the to-do matching the ID has been toggled between done and not done. Anyone who's used Redux here will recognize this pattern. This is very similar to what Redux does. They do a bit more work around it. But the general idea is pull out functions that can work on your state and data that are isolated from your React components. Testing this add to do function, for example, is then really easy. So I create my initial state, which is an object with to-dos where I've got an array with one to-do in. And then I create my new state by calling the add to do function. I give it the initial state and I give it the new to do. And I can assert that the second to do in the array is equal to that to do I just added. There's no knowledge here about React. There's no setup of React. There's nothing to boot my application, as it were. I'm just testing plain functions. So I'd really encourage you to do this as much as possible. But of course, that's probably not why you're here. We're probably here to learn about testing React components. So let's start looking into that. So the first thing we're going to do is actually test the to-do component. So not the big list. We're going to test an individual to-do component. Just to give you an idea, it takes in three properties: the to-do, which is an object, the done change function, which it should call when we toggle a to-do between done or not, and delete to-do, which should be called when the user hits the delete link. Just again, more to give you context than anything else, this is a rough version of the code. I've stripped a bit out to save some space, but this is the general idea. So we render the to-do, we give it this extra class of done-to-do if it's done, and that's what applies the strike-through styling. Then I have a link to toggle it, and we call toggle done, and I have a delete link as well. The toggle done function just calls the done change, passing in the ID of itself, and the delete to do function does exactly the same, just passes through the ID. So there's three bits of functionality here that I would probably want to test. The render div element is given a class of done-to-do if the to-do is done. Deleting a to-do will call this.props.delete to-do with the right ID. And clicking on a to-do calls this.props.toggle done with the right ID. So the first thing we're going to do to start testing React components is install the React add-on called TestUtils, which we install just through npm. This link there takes you to the full documentation for the TestUtils. And to start with, we'll look at shallow rendering. So this is when you can test your React components without actually needing a DOM in place. So rather than actually render your components to a DOM and test them that way, how shallow rendering works is we instead get an object back that represents what would have been rendered to the DOM. You can then make assertions on that object and no DOM rendering has had to happen. This keeps your tests a bit quicker because you don't have to go through the bootstrapping a DOM and rendering to the DOM and making assertions on it. So this is how we create a shallow renderer that we use in our tests. So I import the TestUtils here. In my function shallow render to do, I first create a renderer using the TestUtils create renderer call. Then I call renderer.render and I pass in it, I pass it my element, my component that I want to create. So in this case, I'm going to render a to do element. I'm going to pass in the to do, and I'm also going to pass in this done change and delete to do functions that the to do component expects. And then we return renderer.getRender output. What that's going to do is it's going to give us a massive JavaScript object that represents what would have been rendered to the screen. I should as well, this whole create renderer and get render output, you tend to abstract that into a function that you will call, so you only have this code once. The output from this looks somewhat like this. Now, I've removed a lot of the keys and values from this object to fit it on a screen and to also just show the important bits, because there's a lot of this stuff that isn't that important for this particular talk. But you get back this object that represents what would have been rendered. So it's a, oh, whoops, excuse me, I clicked too early. It's a div. It's got these properties so that you can see the classes that have been applied. And here's the children element. So there's my paragraph with the properties and my anchor that says delete as well. But now we can make assertions on these. So for example, if I wanted to assert that we render the text of the to-do onto the screen, I could create my to-do with an ID, the name of buy milk and done false. I could call that shallow render function we just created and give it that to-do. And then I can test that this is rendered. So I can assert that the result props children, the first one, its children is buy milk. And this will work, and this test does indeed pass. I could then say check that a done tweet gets the additional class of done to do. So this time my to do has done true. I shallow render it, and now I assert the class name prop of the result has the done to do class applied to it. So this works quite well for testing kind of things that you don't need user interaction in. There's just kind of assertions you want to make on the rendered output without having to simulate a user click or anything. It can be a bit messy to do kind of this result props children, not props children. This test in particular is more of an example. I wouldn't write a test that checked that every single bit of my output, renders the right text, for example. I'd like to think that kind of thing I'd notice as a developer if it wasn't rendering the text of it to do. So I wouldn't write lots of tests like this, but I would write that the right class is applied, because that's something that I could more easily miss when I was working on a feature. So that's how you can test things that don't need user interaction. But for testing user interaction, we do actually need to fire up a DOM and render our components properly. Now, you could do this by writing tests that we run in a browser. However, I really like being able to run tests in Node. This way I can have my tests run at the command line. I don't have to go into a browser to look at the result of them, and so on. So React components will always have state like to-dos that the user can edit. And we can test these by faking user input and then checking the rendered output. You should never reach into a component to get or set its state directly, because that breaks the abstraction, if you like. React's abstraction layer from an input point of view is your input is your user's actions and your output is the rendered output of your components. And you should respect that in your tests as well. Your tests, the way I think about it, even your unit tests in your React components should act as if they're a user doing stuff on the page. So to set up the DOM, I'll use JS DOM. JS DOM is a full DOM implementation, but in Node. This means that I don't need a browser. I can keep my tests purely in Node. So I'll install JS DOM. I have to do a bit of setup to create my DOM in the node environment. So I set this global, which is the node global variable. I set the document property to be a JS DOM instance, and I set the window and navigator as well. This is enough to set up a DOM in my node environment and trick React into thinking it's being run in a browser, so it will render to the DOM. And all React calls will work perfectly correctly. It thinks it'll be rendering to a browser, but it won't. It'll just be rendering to a JS DOM. So in any React test now where I need a DOM, I just need to import my setup.js script, which I just had on the previous slide, and that will create my DOM for me before my tests are run. So for example, let's test toggling a to-do. So this means that you can click the to-do and see that it is toggled between done or not. So the first thing we'll use is this TestUtils render into document, which will render a component into a DOM node. Note that it's a detached DOM node, so we don't actually need to clear up the DOM between each test because these elements are rendered into a DOM node, but that's not put into the body. So it's really nice for that reason because we don't need to do any clear up between tests. So this is the most of the test. So what we're testing here is when I click to do the done callback property is called with the right ID. So I'll create my callback, which will take the ID and make the assertion that the ID is set to 1. I'll create my to-do, which will have an ID of 1, and it will be the buy milk to-do. I'll call render into document and pass in the to-do and pass in the done change prop, which is the one I want to make assertions on. And the final thing I need to do is actually simulate the click. To do that, we first need to find the element to click on. So we'll use the TestUtils find render DOM component with tag function. These are pretty snappily named, as you can see. They're quite long-winded, but they are very explicit, which is nice. We'll look in a minute about a library that actually wraps around these and gives us a much nicer way of working with this stuff. And finally, we'll simulate a click. So if we found this paragraph and stored it into the to-do text,
Hi, Jack, are you there? Jack. Folks, it looks like Jack is probably having some technical issues. Let's just give him a minute. Folks, sorry about this. I'm just going to quickly try to reach him. He should be back up and working in a bit. see. Hopefully this will get. Yes, it's the same presentation. I'm quickly answering a question. It just seems that the speaker, his internet connection just cut out. So I'm just giving him 5 more minutes. Hopefully he'll be able to rejoin us, folks. Ladies and
Oh.
gentlemen, Jack is back.
That went pretty smoothly. Cool. Apologies for that. I literally just finished presenting and realized that my internet, I don't know what happened. But anyway, I'm here now. So sorry about that. Where did I get to before you lost me?
Yeah, right before I lost you, you were speaking about your slide was firstly find the component on the page that we want to click on the constants
Okay.
equals test.utensils.
Okay. So had I mentioned Enzyme?
Negative.
Okay. Right. Have you seen the testing the to-dos component?
No, that was your slide that you were showing on screen.
Okay, great. Okay, all right. So, okay. Let's go from here again then. Apologies for that, everyone who's watching. And I have honestly no idea what happened. My internet didn't seem to cut out at any point. Oh, well. We'll go from here then.
Sounds good.
Cool. So apologies again. Right. So the point here is so far we've tested these individual components like the to-do component and the add new to-do component. However,
can you share your screen?
Oh yeah, sorry. It's all going wrong. Okay, so can you see my slides?
Testing the to-do components.
Yeah. Is that where I was at? Is that the right place?
You were past the, yeah, you were like a few slides into it.
Okay. All right. I'll just go from here then, and then we've got it all. Cool. All right. So apologies again. So the point here with this is we tested the to-do component and the add new to-do component in isolation, but we haven't really got any tests that overall our application is mostly working. So these tests will kind of cover the overall logic a bit more. They're almost a tiny bit kind of integration tests in the way that these tests will kind of indirectly test lower level components as well. This doesn't mean if you had a much bigger React app, you test the kind of whole thing in one big test, but for bits where you've got maybe 2 or 3 subcomponents working together, it's nice to write 1 or 2 tests to make sure all those components are working together too. So the to-dos component is pretty large. I don't really need to show you too much of the code. It just renders the list of to-dos here and the add to-do form down here. So for example, let's write a high level test that when I add a to-do, it will get inserted into the page and the user can see it. So the first thing I'll do is render the to-dos component like so. I'll then locate my input value, or my input element on the page with find render DOM component with tag. I'll set the value to buy milk. I'll then find the button using the same function, and I'll simulate a click on that button. The assertion I'm going to make is that a new to-do is added into the page. So in my case, the application is actually hard-coded to start with 3 to-dos. I hard-code some into the state. So I'll now assert that the length of the to-dos is equal to 4. And to do this, I use this weird method called scry render DOM components with class. And for the longest time, I had no idea what this meant. Scry render DOM components with class will find all components with the given class and gives us back an array of them. This definition comes from the word scrying, which is the practice of looking into a translucent ball. So it's like a crystal ball kind of person gazing into it and seeing your future. Of kind of weird note, but I always wondered why that method was called what it was. And then I think just before I did this talk in Amsterdam, someone pointed that out to me and sent me a Twitter link. So that was much appreciated. So just thought I'd mention that. So our whole test ends up looking somewhat like this. We render the whole component. We find the input, we fill it in, we click the button, and we assert there's now one more to do on the page. So that's a kind of high level test that some of our components are interacting correctly. However, as you might have noticed, TestUtils is pretty verbose. And I'm not the only one to notice this. Airbnb released a library called Enzyme, which is a nice wrapper around these tests, which makes it nicer to work with. It's a library around the React TestUtils with a much nicer API, effectively. It's also unopinionated in terms of which JavaScript framework you want to use, whether it's Mocha, Tape, Jasmine, Jest, all the rest of it. So again, not test framework specific. So I installed it through NPM. So Enzyme makes the API for shallow rendering much nicer and the API for actual DOM rendering nicer too. So if we start looking at shallow rendering, Enzyme gives us a function called shallow, which we can just call with a React component, and it will shallow render it for us. So remember earlier I had this shallow render to do function, which is it was much more complicated. I had to call like testutils.get rendered output and all the rest of it. Now I can just call shallow from Enzyme. And my API for finding data in that shallow rendered output is much nicer. So I can call result.find, give it the element I want to search for, then call .text to get the text of it. So it's a very jQuery-like API, which reads very nicely and is much more intuitive and easier to work with. There's a link there to the full API docs on them. We can also, it makes it much easier to test user interactions too. I can import this mount function. I can import this mount function. This will just take a React component and render it into the DOM. I can then use this form.find input to locate my input field much nicer and set the value. And then again, I can use form.find button.simulate and then give it click as an argument. So the API for Enzyme is way neater, nicer, still very explicit and clear, but a bit more succinct, which is very nice. As a final bonus, it's also possible to take all these tests and run them in the browser. So I like working in Node most of the time because it's a quicker feedback loop. I can run my tests in the terminal through my editor, and that's really nice. But of course, when we're building browser applications, it's important to test in the actual browser. So to do this, you can use any form of bundler, Browserify, Webpack, or the rest of it. Effectively, create one big bundle of all your tests. So here I take all my tests, I transform them through Babel, and there's just two files you have to exclude from Browserify, else it will error. Tape has a module called tape run, which will run our tests in a browser for us. Mocha, I think, supports this out the box, as does Jasmine. Jest might do, or there's a plugin to make it happen. So I basically bundle up all my JavaScript and I give it to tape run, and I tell it which browser to run in. In my case, I'm just using Chrome purely for example. And then I can run this all this code, and you'll see that tape fires up a browser for me. You won't see any output in there, but my tests are being executed, and I'll get the results in my terminal there as well. So although I work mostly in Node, maybe just before I deploy, I'll do a final run through while I test everything in the browser too. This is easily automated through like Source Labs or Browser Stack or one of those type of companies. So just to wrap up, and again, I'm sorry for the drop connection halfway through, not in
Jack, oh, looks like we lost him. A second time, he's gonna send this. I'm gonna send him a quick email to let him know. course, I'm just gonna give them another 5 minutes.
Hey,
There we go. And
my word. So I'm currently tethering to my phone because my flat internet has decided to completely drop out on me. So hopefully you can hear me okay.
yes, sir. I'm gonna quickly let you know the last thing you were showing was your terminal.
Okay,
Basically, I think you just finished using
just here, yeah. Let me share my screen. I can only apologize. I've no idea what's going on with this one. Cool. So you can see my screen?
correct, yes.
Okay, so we were here. Do you recognize this? Is this?
Yes, there's one.
Yeah, great. Okay, so we actually got nearly everything. So that was just showing that you can run the tests in the browser. The final bits are just wrapping up really and saying, let's do some questions. So there's a link here to a blog post. The repository on GitHub is at to-do-react-testing. The slides are on Speaker Deck already because I've done this presentation live at React Amsterdam before. And if anyone doesn't manage to ask a question during this live stream but is watching it back or anything and wants to ask me a question, just find me as Jack_Franklin on Twitter. And I also blog at javascriptplayground.com. So that's absolutely it. That's all I had. I'm sorry about the internet. Who knows what's happened there, but I'm happy to take questions if people have any.
Definitely. Okay, so let me get our first question.
And let me find some of those links in a minute as well.
Okay. Our very first question is it equally important to write tests for personal projects?
I think that kind of depends really on your preference. I like to do it on any project that I know I'll be working on probably more than a couple of times. You know, for like a one-off hack day or a weekend hackathon that you're at, I wouldn't bother with tests because it slows me down. But if there's a project I think I'm going to be working on for a decent period of time, then yes, I would write tests.
Okay.
But again, it's more kind of personal preference how many you want to write.
Well, there you have it. Our second question is, any thoughts about AVA versus tape?
So Ava is another kind of testing framework. I don't really have any thoughts. I've tried Ava and I liked it. Personally, I enjoy kind of how bare bones tape is. Ava does a lot of cool stuff though, like it sets up Babel out of the box. It has really good support for like async tests. It runs them in parallel. It has a really good watch mode, etc. So it's really nice. I don't not like it at all. I just personally I like sticking with tape. But that again, that is 95% personal preference more than anything else. So, you know, I'd encourage people to play around with a few of the test frameworks and pick the one that works best for you.
Okie dokie. Our next question is, we use React with RxJS. Any thoughts on testing hot observables on components?
This isn't something I've personally done, so I don't want to talk too much about it, or because I can't really talk with any authority on this. From what I imagine, I can't imagine it would change my testing approach too much because I still like to test input as user input and output as kind of the rendered components. I haven't done anything more like specific on RX and React though, so really that's all I can offer there, I'm afraid.
All right. And our last question is, let me just get it from 1 second. Any thoughts on automated integration tests? Are they needed in React applications, or is testing single components / reducers enough?
So I'm presuming this person means things like the kind of end-to-end tests where you fire up a browser and actually click around. I think they are not needed as much. From my personal experience with projects, those tests tend to be very brittle and they can often just completely kind of break, or they'll fail randomly just because the act of clicking in the browser, then you have to wait for that click to happen. There's often a load of problems around them. I found myself not needing them as much in React, I think because the tests I write do simulate clicks. I would still be tempted to maybe have 1 or 2 very high level overview tests, maybe at your 1 or 2 most key like user journeys through your app. But as a whole, I find that they're not needed as much. And I find actually, for me, I'm more comfortable with thorough tests on the components and, like, as this person said, the reducers, and then worry a bit less about the high level kind of end-to-end tests. I'd probably still write a couple, but they wouldn't concern me as much.
All right.
Again, though, a lot of that is also can come down to personal preference and what you and your team want and prefer most of all.
All right. Well, Jack, that seems about it.
Cool.
Thank you very much once again for coming. Big thank you to Jack Franklin for taking some time and showing us how to test those cool React apps. As always, folks, if you always want to check out our other events, bmap.com is where we have our live updates. So you can check out upcoming webinars, hackathons, and our meetups as well. So with that, have an awesome day, depending where you're at, and cheers till next time.